This video is on how to perform a one-way ANOVA in Quantum Excel. First, we want to make sure that Quantum Excel is running. You can see at the top that there is QXL Monte Carlo, QXL Stat Tools, QXL DOE. If you don't see those, then Quantum Excel is not running. There's another video that explains how to start Quantum Excel. Notice that I have my data. Supplier A data is in column A, and the supplier B, C, and D are in columns B, C, and D respectively. To start, I'm going to pre-select my data, so I'm going to select cells A1 through A11. That is the data range that I'm interested in performing the one-way ANOVA. And then I click on Hypothesis Test, Test for Mean, and then One-way ANOVA. When I click on One-way ANOVA, the first thing it asks is the data range. I've already pre-selected the data, and so I don't need to do anything. But if I had forgotten, then I could select the data now and select range A1 through D11. Note the checkbox, my data has a header. Quantum Excel checked that automatically because it saw non-numeric values in the first row, and it assumed that those are headers. Then I click on Next, and when I click on Next, Quantum Excel is going to ask me, is the data orientation in columns or in rows? The first option at the top is that the data is in columns, and that's the way our data is oriented. We see this example of vendor 1, vendor 2, vendor 3. It matches our data set where suppliers are in columns. If I have my data in rows, then I would just click down here, but Quantum Excel guessed correctly and assumed that the data is in columns. Then I'll just click on Finish, and when I click on Finish, Quantum Excel is going to create the results for me. The null hypothesis is that there is no difference in the population means. For that to be true, that would mean the population mean for supplier A is equal to the population mean for supplier B, which is equal to the population mean for supplier C, and then all the way through supplier D. So they would all have to be equivalent in order for the null hypothesis to be true. The alternate hypothesis is that means are different and only requires one of them to be different than the other three, or all four can be different. But if any of them are different from each other, then the null hypothesis is no longer true. The p-value is located down here, and you can see the p-value is 0.0023 because that is lower than the alpha crit or the decision criteria of 0.05. Quantum Excel displays rejected next to the null hypothesis, so we are very confident we have sufficient data to say there's a difference in means. The alternate hypothesis is accepted, which of the means are different. If I scroll down, we can find out which one of the means are different. Now, this part is a little bit more difficult to understand. You can see that this is the 95% confidence interval for two-key simultaneous tests for difference in means. You really shouldn't go do a t-test now. A lot of people go do pair t-test or just t-test at this particular point, but you shouldn't do that. The reason is that we have multiple hypothesis tests being tested at the same time, and so this two-key honest significant difference is a way to account for the fact that we are doing multiple tests simultaneously. And what this is essentially what is the confidence interval for the difference between supplier D and supplier C's mean. Another way of looking at this would be mu D minus mu C, and mu D minus mu C falls in the range of here to here. So that range of here to here, notice that it does not include 0. It starts at about, let's call that approximately equal to 2, and then it goes up here to approximately equal to 12. So that range does not include 0. Because that range does not include 0, we are now greater than 95% confident that there is a difference between supplier D and supplier C. However, when that confidence interval does include 0, so note the one just below it where supplier D minus supplier B, that range goes from about -5 to about +6. It does include 0, so there is insufficient evidence to say that supplier D is different from supplier B. The next one, supplier C minus supplier B, again, does not include 0. So this range right here, this line is 0. Because 0 is not included in that range, we have sufficient evidence. We're 95% confident that there is a difference in means between supplier C and supplier B. And then the last three all include 0, and so there's insufficient evidence to say that there's a difference between D and A, between C and A, and between B and A. And that is how you perform a one-way ANOVA in Quantum Excel. Hypothesis tests are generally categorized into one sample test, two sample test, and more than two sample tests, sometimes called in-sample test. The one-way ANOVA is an example of an in-sample or more than two sample test. The exact same technique I just used can be used for other in-sample tests, such as Bartlett's test, Mood's median test, and the Kruskal Wallis test.